Hello class, this is a continuation on problem solving using trigonometry. So let's go straight away into this. In this first set of problems, you'll see that they're just descriptions of triangles without actual, well, real world problems in this one. So let's interpret this first. We are being given that the angle TUV is 90 degrees. So we can actually draw that already. So here is TUV is 90 degrees. That is T, that is U, that is V. And we're going to close that in because we know it's going to be a right angle triangle. It's saying that UT or TU is 5, so we can write that as 5. And VT is 10. That's going to be 10. It's saying find angle UTV. UTV, we are looking for this angle here. So let's label that theta. And now that we have this triangle, it's just a matter of, well, determining the correct ratio. In this one, we have the adjacent and the hypotenuse. Well, adjacent and hypotenuse is cos. So let's write this as cos theta equals adjacent over hypotenuse. From here, we take the inverse, so cos inverse of 5 over 10, and that is what we type into our calculator. Shift cos of 5 over 10, that gives us exactly 60 degrees. That's our first problem. Let's now tackle the second. You can, of course, pause and give this a go yourself. So here we go. Let's calculate angle XZY given triangle XYZ has Y, and I know there's a lot of like letters going on here, but let's break this down. We have a triangle XYZ, but we're being told specifically that angle YXZ is 90 degrees. Let's draw that exactly. YX and Z. So we're saying that's Y, X, Z. We're being told that that is 90 degrees. And once again, let's close that in because we know it's going to be a right angle triangle. So we're being told to calculate angle X, Z, Y. So we're calculating this angle here. Let's label that. It can be any symbol. I'm going to use the commonly used one. So that one is theta, and this one is phi. So calculate angle XZY given this triangle has the 90 degree here, which we have. And we're being told that XY is 3.2. It's in centimeters here. And XZ is 2.3. And that is how we would interpret this worded problem into a triangle. And now it's just a matter of determining is this sine, cos, or tan. Well, in this instance, we have no hypotenuse, but we have the opposite and the adjacent. So this is going to be tan. So tan of the angle is equal to 3.2 over 2.3. From here, I hope we're familiar now that to find an angle, we must always do the inverse trig ratio. So in this case, inverse tan of the input that we have. So 3.2 over 2.3. So typing that in, inverse tan of 3.2 over 2.3. This gets us 54.293 dot 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 dot. And for trigonometry, we often convert this into the nearest minute. So phi equals 54 degrees, and rounding this up to get us 18 minutes. And that is the first set of these problems. I hope that's given you an insight into how we can interpret these, well, in this case, rather simple worded problems into a triangle, and then solving that problem using trigonometry. Hope to see you in the next video where we tackle on a slightly more challenging worded problem. Hope to see you then. Best of luck.